Alright guys, so this just happened. After recording for, I don't know, 15 minutes, I realized that I didn't freaking press record. Or, I don't know, when I tried to zoom in, it just stopped. So I had finished all of this before I realized that. Anyways, let's do it again. Alright, so let's get started. Alright, so here we're going to graph the parent functions of sine and cosine, and then cosecant and secant. And honestly, that's where I'm going to stop with this video. And then tomorrow we are going to do tangent and cotangent together. Probably not tomorrow, maybe the day after tomorrow. Alright, so for sine, I printed out these little unit circles so that we can see what it is that we are graphing. So for sine of pi over 4, so if you remember, pi over 4 is here. Sine of pi over 4 is going to be our y value. So sine of pi over 4 is square root of 2 over 2. And square root of 2 over 2 is equivalent to 0.707. So I'm just going to write that down because it's going to be easier to graph. Alright, sine of pi over 2 is 1. Sine of 3 pi over 4 is going to be square root of 2 over 2. Sine of pi is going to be 0. So 0.707 and 0. Sine of 5 pi over 4 is going to be negative square root of 2 over 2. So it's going to be negative 0.707. Sine of 3 pi over 2 is going to be negative 1. And then sine of 7 pi over 4 is negative square root of 2 over 2. So negative 0.707. And then sine of 2 pi is going to be 0. And of course, when x is 0, this is also going to be 0. Alright, so when we go to graph this, it's pretty straightforward. I'm just going to graph my x's and my y's. So at 0, we start at 0. At pi over 4, we're going to be at 0.707. I'm not really going to graph all of these points. I'm just going to focus on the main points, which is pi over 2, pi, 3 pi over 2, 2 pi, and of course 0. But these will help us to kind of see where the graph is going. Right, so at pi over 2, it's going to be 1. At pi, we're going to be down at 0. At 3 pi over 2, we're going to negative 1. And at 2 pi, we're going to go to 1. Connect my wave function. Remember, don't make it a V. It is a wave. And then to graph the second side of this graph, you basically just continue the wave. So it's going to go down. So at negative pi over 2, instead of being at 1, we're going to be at negative 1. And then at negative pi, it's going to be at 0. At 3 pi over 2, we're going back up to 1 and then down to 0. And then connect our wave function. Alright, so that's pretty straightforward. So our domain, we know, is all reals. We talked about that today in class. Our range is from negative 1, the lowest that it goes on the y value, all the way to positive 1. So negative 1 to positive 1, and of course they are both included. Now our amplitude, if you remember from our definitions, is basically half of the value from the absolute max to the absolute min. So the value from the absolute max to the absolute min is 2 points. So half of that is going to be 1. And I know they're going to be in 2 separate videos. That's because I don't know what happened and it paused, so I have to put them up as 2 parts. Alright? Now our period, the idea is when does this function repeat? So our period, if I was to start at 0, this is a hump that goes up, this one goes back down, and then at 2 pi, I'm just going to start repeating. I'm going to go up and go back down and go up and go back down. So our period changes every 2 pi. So from 0 to 2 pi, it is one period. And then after that, it just starts repeating. So our period is going to be 2 pi. Now our zeros are obviously the x-intercepts, and you notice that the zeros in sine function are at the whole number pi values, so negative 2 pi, negative pi, 0, pi, 2 pi, 3 pi, and so on. So we are not going to write all of those, so you write it in the form of an equation. So you say that x is going to be at basically all of the whole number integer pi values. All right, so remembering that this is whole numbers because it's the integers. And then our absolute max is at y equals 1, and our absolute min is y equals negative 1. No need to review that. All right, next up is for our cosine. Oh, right here. So cosine, bring back the unit circle for a second. So let's look at our cosine. So cosine, remember, is going to be your x values. So at pi over 4, my x value is square root of 2 over 2. So remember, from the previous one, we rounded that off to 0.707. At pi over 2, it's going to be 0. At 3 pi over 4, it's negative square root of 2 over 2, so negative 0.707. At pi, it's 1. At 5 pi over 4, it's negative square root of 2 over 2. At 3 pi over 2, it's 0. At 7 pi over 4, it's square root of 2 over 2. And then at 2 pi, it's going to be 1. So I'm just going to fill those in. So at pi was negative 1. At 5 pi was negative 0.707. At 3 pi over 2 is 0. At 7 pi over 4 is 0.707. And then at 2 pi, it's 1. And then, of course, at 0, it's going to be also at 1. All right, so when we go to graph this guy, at 0, we're going to start at 1. At pi over 4, it's going to be at 0.707. At pi over 2, it's at 0. At 3 pi over 4, it's at negative 0.707. At pi, we are at negative 1. All right, I'm not going to graph the 0.707s. I'm just going to graph the main ones. So at 3 pi over 2, we go back up to 0. And then at 2 pi, it's going to be at 1. And then the pattern continues on the other side. Okay, so this is obviously one period because on this side, at negative pi over 2, it's going to be at 0. And then if it continues going down, at pi, it's going to be at negative pi, sorry, it's going to be at negative 1. And then 3 pi over 2, or negative 3 pi over 2, is going to be again at 0, and then at 1. All right, so there's our cosine function. All right, so now let's identify our domains and all that fun stuff. So our domain is pretty straightforward. So here the domain is all reals. The range, again, is just from negative 1 to 1. The amplitude is basically from your max to your min, what is half of that. So our A is going to be 1. our period is when does this thing repeat? So if I start at 0, from 0 to 2 pi, the graph begins to repeat. So here our zeros are a little bit different. So our zeros for this function, you notice, are not at the whole integers. They are at all of the halves, actually. So we can't say like we did up here, which is it's at x equals n pi. We actually have to identify that it's at x equals pi over 2, but it's not just at pi over 2. It's at pi over 2 plus or minus n pi. Now the reason that this works out is because, I'm just going to do this on this sheet right here, just an example. So if I start at pi over 2 and I add pi, just 1 pi, right? So n being 1, what do we get? So in order to add this, remember, it's a fraction, so you need a common denominator. So let's get a common denominator of 2. And because I multiplied the bottom by 2, of course I got to do that to the top. So when you add these, what do you end up with? 3 pi over 2. And of course, we have our 0 at 3 pi over 2. And this will work for pi over 2 plus 2 pi. So if you make a common denominator, this becomes a 2, this guy becomes a 4. So guess where our next 0 is? At 5 pi over 2, and so on and so forth. So instead of writing all of that down, we use this equation. It's very important for you to remember these equations because they're going to help you identify the asymptotes as well as zeros in the other functions. Now here the absolute max and absolute min is the same. Y equals 1, y equals negative 1. So we're good. All right, before we do tangent, I'm actually going to do the cosecant and the secant, since we have sine and cosine fresh in our mind. Now remember that cosecant is just the inverse of sine. All right, so before I even think about the cosecant function, what I want to do really quick is I just want to draw the sine function here, just dotted, just so you can see the similarities in a minute. So I'm just going to plot the points, and I'm going to graph this just with a dotted line because this is not what we want to graph here, but you'll see why in a minute. All right, now identifying the values. Okay, I'm only going to do this for one of the values because just like in sine, if pi over 4 is 0.7007 and 3 pi over 4 is 0.707, the same thing is happening on the other side, and I'll show you why. All right, so let's look at the graph at our unit circle. All right, so remember that cosecant of x is equal to 1 over sine of x. So our first point is going to be pi over 4. So cosecant of pi over 4 is going to be 1 over what our sine was. And what was our sine? It was square root of 2 over 2. Now to solve this, we actually have to multiply by the reciprocal, which gives you 2 square root of 2. But of course we can't have a rational denominator, so you rationalize that. So times square root of 2 over square root of 2, and you end up with 2 times square root of 2 over the square roots cancel out, so you end up with 2. And then what happens to 2 over 2? That is gone, and you're left with just square root of 2. And square root of 2 is what our y value is for pi over 4. And square root of 2, if you put it in the calculator, is approximately 1.41. All right, now for pi over 2, it's a little bit easier. So for pi over 2, it's 1 over sine, and sine is just 1, so it's just 1 over 1. So for cosecant of pi over 2, it's 1 over 1, which is just 1. So that's pretty straightforward. Now 3 pi over 4 is also going to be 1 over square root of 2 over 2, which is the same as the problem that we just did. So this just ends up being 1.41. For pi, now this is where it gets a little funky. All right, so for pi, what's our sign? Our sign is 0. And what is 1 over 0? Good, undefined. And that is what is happening at pi. So you notice that whenever sine was 0, what's happening to cosecant? It's going to be undefined. So I now know that at 2 pi it's undefined, and at pi it's undefined. At 5 pi over 4, it's going to be negative 1.41. At 3 pi over 2, it's going to be negative 1. And at 7 pi over 4, it's going to be negative 1.41. All right, so I'm going to come over here and I'm going to graph this. So let's graph these points. At pi over 4, it's at 1.41, so about right there. At pi over 2, it's actually right on that point. At 3 pi over 4, it's at 1.41. At pi, though, it's undefined. So what's happening at pi? Yep, we have an asymptote. Then again, at 5 pi over 4, now here we are at the negative. At 3 pi over 2, we are at negative 1.
For how long?
Sorry, that was Siri. I don't know what happened. All right, at 7 pi over 4, it's at negative. And at 2 pi, we are undefined. So we have an asymptote. So you notice that wherever there was a 0 on the sine function, we actually now have an asymptote on the cosecant function. So I'm going to go ahead and draw all my asymptotes at the zeros. And now I'm going to connect my dots where the graph is approaching the asymptotes. So you end up with a bunch of these little parabolas. All right, and you notice that the parabolas are at the max and mins of the sine function. So here is another parabola, and then here is another parabola. All right, so the black ones is our cosecant function. Remember, I only dotted the sine function so that you can see the similarities between the two. All right, so now when we actually talk about the domain and the range, it's a little bit different. Because now our domain is not all reals. Our domain is almost all reals except at those asymptotes. So we actually identify that as x cannot be plus or minus n pi. And where did you see that before? At our zeros. All right, and then your domain is basically identifying your asymptotes. So this equation is going to be actually your equation for your asymptotes as well. But instead of saying is not there, they actually are there. So x equals plus or minus n pi. All right, our range is also going to be the inverse of sine. So our range for our sine function was from -1 to 1. but our range here is actually everything but that. Well, -1 and 1 are included, but the points in between are not. So our range is actually from -infinity to -1, -1 being included, union, and then it picks up again at 1 to infinity. All right, now because there's no absolute max or min, then there is no amplitude. Because remember, the definition of amplitude is half of the distance between the absolute max or min. And do we have any zeros? Does this graph touch? Do these parabolas touch the x-intercepts? Nope. Now the period is the same. You have an up-facing parabola, a down-facing parabola. The next one is going to be an up-facing parabola. The next one is going to be a down-facing parabola. So our period is still 2 pi. Because just ask yourself, when does the graph just copy and paste itself? So our period is still 2 pi. All right, don't want you guys to worry right now about relative max and relative min. We'll talk about those at a later date. All right, now secant. So again, just like what I did with the previous guy, I'm going to graph the cosine function here really quick. Remember, it looks like a cup. I just messed that up, my bad. I don't have whiteout to fix that. Okay, please ignore those 2 points. That is my fault. All right, so now the secant is the inverse of cosine. So I'm just going to start this off right here. So to fill in our table, at pi over 4, our cosine was square root of 2 over 2. But if you remember, secant of x is just 1 over cosine of x. So here cosine of x is square root of 2 over 2, so it's 1 over square root of 2 over 2. And of course, just like with cosecant, you have to multiply by the reciprocal, which gives you 2 over square root of 2. We can't have a rational in the denominator, so we multiply to rationalize the denominator, and we end up with 2 square root of 2 over 2, and then of course the 2's cancel out, so we're left with square root of 2 over square root of 2. And just like before, square root of 2 is rounded to approximately 1.41. All right, now at pi over 2, you notice, at pi over 2 we have a 0. So what is 1 over 0? Undefined. Because remember, they are inverses. So if cosine has a 0, then its inverse is going to be undefined. So where are my other undefined points? They are going to be at 3 pi over 2. So at 3 pi over 2, I have another undefined point. And then I can use what's here. What's at 3 pi over 4, it's going to be 1 over negative square root of 2 over 2, which we figured out to be approximately 1.41. At pi, it's going to be 1 over, let's look at pi. At pi, it's going to be 1 over negative 1, which is negative 1. At 5 pi over 4, it's going to be 1 over negative square root of 2, so it's negative 1.41. At 7 pi over 4, it's going to be 1 over positive square root of 2, so 1.41. And then at 2 pi, it's going to be 1 over 1, which is 1. All right, so let's go ahead and graph those points. And you'll see something similar happening. So before I do anything, I do want to draw my asymptotes that go through the zeros. So here are my asymptotes. Remember, this is not the function we're graphing. I'm just drawing it so you can see the similarities between the two. All right, and then on this side we also have our asymptotes over here and right here. So at pi over 4, we are at 1.41. At pi over 2, we are undefined. At 3 pi over 4, we are at negative 1.41. At pi, we are at negative 1. At 5 pi over 4, I don't know why I did this. Sorry, guys. That's what happens when you redo something. All right, at pi, it's at negative 1. At 5 pi over 4, we are at negative 1.41. And at 2 pi, we are actually going to be at 1. And at 7 pi, we are at 1.41. So it does a similar thing to our cosecant function. We have parabolas, and the parabolas are at the maxes and the mins of our corresponding cosine function. So even though I don't have the point, well, I kind of do, because I know that at 0 it's going to be at 1. So even though I don't have all of my points, I know how the rest of this graph is going to look like. All right. Sorry for the messed up function. So the black portions, the parabolas, are basically our functions for secant. So here, the domain is going to be similar to our zeros equation, because the graphs are everywhere except on these asymptotes, and those asymptotes are at the halves. So we say that x cannot be at pi over 2 plus or minus n pi. And the same with our range. It starts at negative infinity and it goes up to negative 1. It is included, union. There's nothing happening in between negative 1 and 1, so it picks up again at 1 and goes to positive infinity. Again, no absolute max or min, so no amplitude. The period is still the same, all right? So if we started right here, so if I was to cover this graph, this is a portion of the parabola, then you have a down-facing parabola, and then you have the second portion of the parabola, and you see this starts to be copied and pasted right at 2 pi. So our period is still going to be 2 pi. Do we have any zeros on this graph? Does this graph touch the x-intercept anywhere? Absolutely not. And asymptotes, they're going to be the same equation as your domain, except we're not going to say does not equal because they are there. So x equals pi over 2 plus or minus n pi. And we're going to cancel. We're not going to worry about relative max or min just now. All right, this video is now 30 minutes long. I don't want to make it any longer than that. So we're going to do the tangent and cotangent function tomorrow. We'll start that in class, and then you guys can possibly do the sine and cosine at home. Enjoy.